In this video, I'm going to walk you through a typical circular motion problem involving a car traveling around a circular track. So this problem tells us that we have a car that's traveling around a circular horizontal track at a constant speed. And it tells us that we have a coefficient of friction between the tires and the road of 0.8, and we want to know what the maximum speed of the car is around the track. So how fast can the car go without spinning off the track? And we're told that the track has a radius of 20 meters. Okay? So the first thing whenever you approach a circular motion problem that you need to do is you need to identify what the force acting on the object is that's causing it to have a circular motion, or in other words, what is the centripetal force? And in this case, the centripetal force is provided by the friction between the tires and the road. So you can imagine as this car goes around the track, there's a centripetal force pointing inward, always toward the center of the track, provided by the force of friction. Okay? And we know from our previous work that the centripetal force is equal to the velocity squared divided by the radius of the circle we're traveling in. And we know from our forces unit that the force of friction, in this case it's dynamic friction because we have a moving object, is equal to our coefficient of friction times our normal force. And in this case, the normal force, because we're just sitting flat on a horizontal track, our normal force is equal to our weight. So mu times mg. Okay? And I know that as this car travels around the track, that the force of the centripetal force has to be equal to my force of friction. Otherwise, the car is experiencing an unbalanced force and it'll spin tangent off the track. Okay? So I know my centripetal force is equal to, oh, big mistake there, mv squared over r divided by r is equal to our force of friction, mu mg. Okay? I don't need to know the weight of the car, or the mass of the car, in this case, because we have mass on both sides. And I'm trying to find the maximum velocity, or the maximum speed. Remember that we're changing direction constantly, so we had changing velocity but a constant speed traveling around the track. And so we find that v is equal to mu gr. Okay, now all we need to do is substitute. Velocity is equal to the square root, our coefficient of friction is 0.8. Our acceleration of gravity is 9.8, and we have a radius of 20 meters. I plug all this into my calculator, and I find that I have a constant velocity of 12.5 meters per second before I would glide off the track, and friction wouldn't be able to hold me in the centripetal path. Okay, that's it for this problem.